안녕, welcome to KMS. Today, we are going to talk about limits. Let's think about this. When x gets really close to 1, or x is exactly 1, is the y value the same or different? Sometimes it is, and sometimes it isn't. Let's figure out what it really means step by step. Alright, let's get started. Here's a graph of f of x, like this. Let's think about this limit expression. We read it, limit as x approaches 1 f of x. What does that mean? This expression is asking, as x approaches 1, what value does y get closer and closer to? It doesn't mean f of 1. f of 1 is the y value at x equals exactly 1. But in this case, there is an open circle like this. That means this graph doesn't have the point 1, 2. This line goes up just before the yellow point, skips over it and keeps going. So we say f of 1 does not exist, or just any. But this limit expression tells us what happens to the y values as x approaches 1. There are two ways that x can approach 1. One from the left, the other from the right. Let's think about the left side first. Like this red arrow, as x gets really close to 1, like 0.5, 0.7, 0.9. The graph is going up from the left, heading toward the yellow point. The y values get closer and closer to 2, like 1.5, 1.7, 1.9, 1.99. It's practically 2. So we say the limit from the left is 2. To say that x approaches 1 from the left, you just put a small minus sign after the 1. And the limit value, the y value, approaches 2. We call this the left-hand limit, or just LHL. What about from the right? You just put a plus sign after the 1 like this. We call this the right-hand limit, or just RHL. Just like before, trace the graph. As x approaches 1 from the right, like this, the y values goes through 2.5, 2.3, 2.1, and 2.001, and eventually get close to 2. So the limit from the right is also 2. When the left-hand limit and the right-hand limit are the same, we say the limit as x approaches 1 equals 2. It really doesn't matter whether f of 1 exists or not. Let's take a look at another example. You can pause the video and try to find all the values. What is f of 1? There's a closed circle right here. That means the function is defined at x equals 1. So f of 1 equals 2. Since the limit from the left goes toward this point, limit as x approaches 1 equals 3. What about the limit as x approaches 1 from the right? From the right, the graph is a horizontal line at y equals 1. That means the limit from the right equals 1. The left-hand limit and the right-hand limit are not the same, so the limit of the function as x approaches 1 does not exist. Now, this one's a little different. The graph only exists on the right side of x equals 1. It actually starts right here. So we say f of 1 equals 0. Let's look at the limit from the left. There's no graph coming from the left side. So the limit as x approaches 1 from the left does not exist. Look at the right side. As x approaches 1 from the right, the y values get closer to 0. So the right-hand limit equals 0. For a limit to exist, the left-hand limit and the right-hand limit have to be the same constant. If not, the limit does not exist. In this case, the left-hand limit does not exist. That means the limit as x approaches 1 of f of x also does not exist. Let's try this one. What is the limit as x approaches 2 from the left? What do you think? Here's the vertical asymptote at x equals 2. As we follow the curve, the y values go lower and lower without bound. Therefore, it goes to negative infinity. Let's look at the right side. If we follow the curve toward the vertical asymptote, the y values keep going higher and higher. So the limit from the right is positive infinity. Now, what is the limit as x approaches 2? Since these two values do not match, the limit does not exist. What about f of 2? F of 2 is not defined, so it does not exist. Let's look at another similar example. What's the limit as x approaches 3 from the left? If you follow the graph from the left side, the y values keep increasing without bound. So, the left-hand limit is positive infinity. Now, from the right. As x approaches 3 from the right, the graph keeps going higher and higher. Same thing here. The right-hand limit is also positive infinity. So, what is the limit as x approaches 3? Both sides are heading toward positive infinity. We can write positive infinity just to show how the y values behave. But actually, infinity is not a number. It just means the y values grow forever. So technically, it does not exist. What is f of 3? F of 3 is not defined. So we just write d and e. That's it for today. I hope this helped. See you in the next video. Bye!